Welcome to the ZCon 6 Technical Roadmap panel. Today we've got a bunch of engineers from across the Zcash ecosystem, and we're going to discuss what the technical roadmap looks like for Zcash going forward. Let's start off with some introductions, and I'll also ask everybody to give a little icebreaker and tell us what you think the future of Zcash is going to be after the sort of NU7 timeframe. Where you hope it's going to go, what sort of features you hope are going to get deployed, what sort of functionality will be added to the protocol. And let's start off with Arya.
Hello, I'm Arya. I work at the Zcash Foundation on Zebra, and I think the future of NU8 and onwards is going to be asset swaps, bridges, proof of stake, and hopefully liberated payments.
Nate.
Hi, yeah, I'm Nate. Let's see, I'm working on proof of stake, so I'd like to see that activate, and I hope Zcash generally heads in a direction of remaining secure, keeping the token limit and issuance rate the same, continuing to provide top-notch privacy, and then beyond that, connecting to many other crypto systems so that it's easy to transfer assets between them using the Zcash network.
Pablo.
Hi, I'm Pablo from Qedit. We are working on ZSA for a while now. So for the future, we were thinking about more mechanisms to enable trading, first of all, inside Zcash, more secure trading inside Zcash, and maybe other tools for helping people onboard into Zcash. This is critical. This can be a bridge, or this can be some other mechanism which is secure cross-chain onboarding, thinking about these directions.
Sean.
Hello, I'm Sean. Yeah, so I work on, mainly these days, I work on long-term research for protocol changes in Zcash. In particular, I focus on things like scalability, scalable payments. So in terms of features and all the rest of that stuff, I don't want to get in anyone's way. I'm really jazzed about all the things that people want to build and integrate into Zcash in the next couple network upgrades. But I think that Zcash needs to succeed at the simplest task, which is to send and receive money, and it needs to scale that simple task to support large numbers of users, which is kind of the dream that I've had since I started working on Zcash since the beginning. And so I'm going to continue focusing on that. I'd like to see there's potentially some changes that can happen before in the next couple network upgrades that can make scalability improvements in Zcash without this all these newfangled cryptography things that I am working on. There's also stuff that I'm excited for. Arya mentioned liberated payments, but just in general, just changes to payment flows that don't actually require us to don't necessarily require us to make changes to the protocol. We can do them outside network upgrades. I'd like to spend a lot of time on that sort of stuff because there's a lot less difficulty in deploying those kind of changes and a lot of experimentation you can do without having to sit around and wait for network upgrades to deploy. So I'm excited about that sort of stuff.
Cool. And Sean, you just finished up a short time ago your own presentation about scalability. So thanks for taking a short break and coming straight back to us.
Yeah, no problem.
Strad.
Hey, I'm Jack, or Strad, answer to both, cryptographic engineer and cat herder at the ECC. And yeah, most of what I do these days is a mix of getting network upgrade related work across the line and shorter term work on things that lead to user adoption. And I'm very interested in things that lead to users being able to use Zcash effectively. because that's the number one thing that matters for as far as the value proposition Zcash provides is its privacy, its anonymity set, the network effect of using Zcash. And so the more people that we can have easily using Zcash, and the more people that we can have bringing their use cases into Zcash, the better.
Thanks, Chad. And last but not least, Zankas.
Hi, I'm Za. I'm with Zingo Labs, and I'm excited about finishing off, I think, an important part of the privacy story, which is network layer anonymity, packet layer anonymity with mixnets, so the NEM integration. I feel like has always felt sort of urgent, and now it seems close to being achieved. I was a little bit surprised to hear other people talk about liberated payments. That's also very interesting to us, and we're also focused on onboarding, and we're really interested in extending the utility of Zcash into the messaging use case. And we're specifically thinking about liberated payments for onboarding folks for the messaging use case.
Well, we had a quick discussion beforehand about an outline agenda, and first on the list was Zcashd deprecation, and I thought it might be interesting to start off with Strad, who has had the misfortune, I think it's fair to say, of having to do a lot of the maintenance of the Zcashd node by backporting improvements from Bitcoin. And I just wondered, Strad, if you could talk a little bit about the sort of the rationale and the reason for us wanting to get rid of Zcashd.
Yeah, so the main reason to want to move away from Zcashd at this point is that the code base is, I mean, we're approaching a decade of adding our own pieces on top of the existing Bitcoin code base, and the maintainability of a stack that has 2 decades worth of design decisions in it is interesting to say the least. I had actually never written C++ in my life prior to starting ECC, and that was my very first job, was to learn C++ 11. So it's always been a little bit of a struggle from that perspective. There's other reasons here which basically come into the part of the reason for starting with Bitcoin as a code base was that Bitcoin had a bunch of battle testing in the ecosystem, in the wider ecosystem, and was seen as a reasonable base to start building the privacy pieces on. But as time has gone on, and the way in which the Zcash network evolves, and the way that the Zcash community decides on deploying changes and things, it has diverged significantly from how the Bitcoin community evolved their network. The difference in effect on the code base in terms of how we make changes, where we make changes, how we integrate them, has meant that it's become increasingly impossible to backport changes and basically keep in sync with upstream, because the review load of doing so is just too high. By switching to focus entirely on a stack that is essentially entirely Zcash focused, we don't have to worry about those kinds of concerns. We can make changes we want. We're responsible for making. That's the other thing. We're responsible for managing the entire stack rather than being able to benefit from what Bitcoin does. But hence, moving to a stack that we understand and that we fully control makes doing so easier to achieve. Yeah. There's also wallet-related reasons that we can get into later if we wish.
And Arya, you've been working on Zebra, getting Zebra to the point where it can begin to take over some of the use cases that Zcashd has always addressed. Can you talk a bit about the challenges of basically re-implementing a protocol from scratch, including all of the bugs and undocumented features?
Yes, so there is a lot to re-implement just to begin with. So Bitcoin was pretty large, and then Zcash extended that And then the specification, while it is very, very thorough, has mistakes in it. And there are mistakes in the implementation of the specification that sometimes Zebra needed to match. I think there were difficulties in terms of what was available to use from a Rust environment. There is still C++ being pulled in for both RocksDB and Zcash script, which will hopefully change soon. So there were a lot of challenges in just re-implementing such a massive system, but then it was also designed in a very modular way that was, I think, pioneering some design patterns in Rust too. So I think the designers really rose to the challenge. And now we have something that's not just focused on Zcash, but also written in Rust, quite clean, quite modular, easy to extend, easy to maintain, moving forward.
And Za, you and your team at Zingo Labs stepped in to help with this process of Zcash deprecation. Can you talk a little bit about the background to that and how you chose, what you're focusing on, and how the experience has been for you guys of getting involved in that project?
Yeah, so we were the maintainers of the Zingo wallet, and we were interfacing with the system through the Light Wallet D proxy that was then sending traffic on to the full nodes. And it was difficult for us to test a bunch of wallet scenarios against the Light Wallet D Go proxy server. We don't generally use Go, as I think is true of most of the participants in the ecosystem were Rust focused. So we realized some time ago that we wanted to replace all that functionality with the pure Rust implementation and extend its test capabilities. So we really were coming to it from a perspective of, we need to control this part of the system a little bit better so that we can know for sure that our wallet is doing what it should be doing with it.
And how have you found getting to grips with some of the foibles of the Zcash protocol? Has it been pretty straightforward, or has it been a challenge to be able to effectively replicate the functionality that the existing Light Wallet D provides?
There are discrepancies between what we expected and what we got, and we found, I wouldn't say that I know that they are surprises in the specification from the Zcash protocol, but there's behavior that we didn't expect coming out of Zebra, as I think is, I shouldn't say unexpected. There's behavior in Zebra that once we started to test, we found that things weren't quite as we expected, and I said it again, that there were unpredicted behaviors in Zebra. And the reason I want to steer away from unexpected is because we actually did expect behaviors that were deviant. We just expected them to come out in our tests, and in fact, they have. So I think from our perspective, it sort of affirms that building out the test infrastructure to see what the thing is actually doing has been bearing some fruit.
So we've got three organizations working on Zcash deprecation, replacing it with a new stack. We've got the Zale, the new CLI wallet that's under development at ECC. We've got Zeno, the sort of indexing middleware, if we want a better description, under development by Zingo Labs, and we've got Zebra under development by the Zcash Foundation, and all three of them rely on core crypto libraries that are maintained by ECC. And the goal here is to move to a new stack that's easier and friendlier to build upon. And at this point, I'm going to turn to Pablo. I'm going to ask Pablo to talk about Qedit's experiences of working on ZSAs in the context of Zcash, and what the experience has been developing on Zcashd versus developing with Zebra as a target, first of all. But then also I want to start talking a little bit about the challenges that we're starting to face in this sort of more decentralized context. Previously we had a single team, ECC, which maintains an entire stack. Now we have multiple teams working on different things, and sometimes two teams are working on the same code base and implementing different features at the same time. So Pablo, can you talk a little bit about your experiences with that?
Sure. So indeed, we started this journey with ZSA. We started it targeting Zcashd, and as we proceed, our first iteration of working ZSA network were built around Zcashd. And in comparison to this, working with Zebra is much nicer. First of all, it's a unified code base. Zcashd has C++ parts, and it has the Rust parts, and it has bridge. The bridge works, but sometimes you need to add manual exceptions, and this is not very nice. In this regard, we don't have C++ code anymore. We are much more satisfied with our changes to Zebra. It's easier to maintain one code base, one uniform code base, instead of having this divide between C++ and Rust. Also, it's easier to understand the underlines. Sometimes you look at Zcashd and you see legacy Bitcoin code from way back, and don't sure how you should react to this. Like, is this actually being used or not? Or maybe sometimes. So we don't have these problems now, and overall, as a developer experience, the developer experience for working with Zebra is much better.
I think you talk a little bit about the sort of stage that Zcash Shielded Assets is at in terms of deployment and rollout, and how you see that plan progressing from here until the point that it actually activates on mainnet.
Yeah. So for the moment, we have a working version of ZSA, meaning we have a modified Zebra node built on top of the entire stack, and the entire stack is the proof system, Halo 2. On top of this, we have Orchard. On top of this, we have Libra Zcash, which is divided into many crates, and on top of this, we have Zebra. All of this we packed into a working ZSA implementation. You can see it online already. In addition to this, we created our own wallet substitute, which is basically a way to generate any NU7 transactions. So because Zebra is not a wallet, we have our own tool to generate transactions just in order to test the changes to the protocol. So it is working, but in the recent weeks, together with the zip editors, there are a couple of changes needed to be done, and each one of these changes, namely, I have the list here. So we added, in the last couple of weeks, we added reference nodes, we added deterministic row computation, we moved burn fields inside action groups, and some other changes. All of these needs to be propagated across the entire stack from the top. We are not touching Halo 2 anymore. We believe that at least the changes for the circuit are done, and they are also externally audited, and this part is ready. But from Orchard and above, the entire list of zip changes, recent changes needs to be propagated all the way up to Zebra and to TX-Tool. Again, transaction changes should also affect on the wallet or wallet substitute. And this is our work as part of the NU7 preparation.
Yeah. We'll come on to the network sustainability mechanism in a moment, Nate, but I just want to first ask Strat about sort of challenges that ECC are facing in terms of resourcing constraints, the need to review the changes that are being submitted to the crates and so on that ECC maintains, and because it's not just a case of Qedit doing the work to implement ZSAs, it also needs to then be merged into the main code base, right? You're muted at the moment.
My keyboard decided to stop unmuting me. Yay, we got the tech issue out of the way. Yeah, no, that's right. The challenge, particularly with something of the scope of ZSAs, and to the extent that it touches the entire stack, getting it in a consistent way that also does not break existing consensus code requires a lot of review and a lot of care in the integration, and doing that takes time away from other tasks. So balancing, figuring out the right time to bring those changes in, so that because it is far easier, for example, for Qedit to develop and iterate and work on the core of the ZSA changes as they did externally to the repo, where they can just make the changes that they want, coalesce things, try ideas, throw them out, and come to sort of an agreement within, internally within them on what needs to happen within that, and that's the role that they're taking on that. Once we get things into the main code base, the advantage there is that integration into testing stacks and integration for testing in other places is much easier because you're not dealing with a parallel stack. But the rate of change of what you can do there, you are now dealing with the changes, the ability to get PRs in. It blocks itself on review, but now you're dealing with like smaller incremental changes working. So being able to make all the larger changes externally is helpful from that perspective. It does just mean that then landing it in is a big coordinated challenge, which we're working through from the ground up. The current, as Pablo mentioned, the Halo 2 side has been pretty stable at this point. Circuit changes are done and audited, and so the current focus with regards to NU7 integration is getting the Halo 2 pieces into those crates. And then once that's in place, then the integration of things like the transaction formats, which has to handle not only ZSAs, but NSM and memo bundles and the other like smaller changes, all of that has to be synthesized together. So bringing the various components in at the right time is also sort of a little bit more of an art than a science for managing the time availability, as well as the when the best time to apply that availability is.
And Nate, Shielded Labs has obviously developed the network sustainability mechanism, and that's kind of, I guess, stuck in sort of development hell, waiting for the bottleneck to clear, what I call the network upgrade bottleneck. But you guys are also working on crosslink or trailing finality layer. I'm not sure what the official name of it is right now. Can you talk a bit about where Shielded Labs sees the future of new features being developed by sort of third parties, and then trying to get them merged in, and how you see the role of an organization like Shielded Labs going forward?
Yeah, let's see, two pieces there. So the first thing, I'm just kind of learning the process and what it's like interacting with these different code bases. So I see potential like challenges and opportunities to sort of streamline some of those things. Like a recent example I was learning about is how transaction parsing, there's some code in Zcash and some code in Zebra, and they're sort of like straddling the fence of responsibility for that. So it means a change like network sustainability mechanism, which relies on a transaction format change, needs to touch both code bases, and then there needs to be coordination, I guess, between 3 different organizations to make sure that that transaction change is like properly merged at the right time. So I guess one thing Shielded Labs is keen on doing, since we're just starting out, the network sustainability mechanism is basically done. It's a pretty simple, small change technically. So most of my focus right now is on crosslink. We're just calling it crosslink because that's less of a mouthful than TFL. What we're hoping to do is the first phase of that development will take quite a while, maybe a year of what we call the prototype phase, which means we're making backwards incompatible changes in forks of the code that we're playing with, just to make a thing that demonstrates the design and works. But we're not necessarily expecting to or relying on merging to upstream. But while we're doing that, we're going to keep our eyes open for ways we can contribute to modifying the code bases or streamlining how the organizations share code. And we really want to highly prioritize that, because the more we can contribute to that upfront, the easier it will be down the road for us to eventually merge crosslink. And that includes, like, in the shorter term, with the fact that we have these network sustainability mechanism PRs sitting and ready, but we need to work as an ecosystem to integrate ZSAs. So in the short term, we can probably chip in here and there where it's easier for outside developers to come in and contribute, like PR reviews or testing or attempting to merge things. So we're hoping to get involved that way.
Cool. And while we're on the topic of crosslink and the proof of stake and whatnot, I'm just going to chuck in a question that came through from Huva. Do you really think proof of stake will increase Zcash adoption? I would like you to share a little bit of your view on this, and let's get everybody's views on this, and we'll start off with Nate.
Okay, so I think it'll increase adoption at least somewhat, because it's providing two new use cases. So one is staking Zcash to earn yield, and the other is running validator infrastructure, or we prefer to call that finalizer instead of validator, because many different kinds of code should be validating things about the Zcash network. But there's like this new infrastructure role available, and it's one that isn't blocked on specialized hardware. So anyone who is interested and wants to run the software and aims to be highly available and so forth can participate in that way. So I think both of those new use cases are interesting, and I expect it'll draw some interest from new users.
And Zah, what are your thoughts on proof of stake? Is this something you're excited about?
Yeah, place to stake. So it gives Zcashers something to do with their Zcash, and you're not paying power costs. So you don't have the downward pressure to spend that you do with proof of work. Will that increase uptake? I didn't say that. I said I'm excited about the potential.
Yeah. Sean, what are your thoughts?
Well, I've been asked this question many times before, and usually it's what do you think about proof of stake in terms of security of the network and things like that? And my answer is always I don't care. That really is not. I really don't care about proof of stake versus proof of work from a security standpoint. It really doesn't matter to me. Now, I just like Nate was saying, and yeah, it's really good. The things it gives people to do, and the involvement that it invites in the protocol, that's really awesome. I think that's good, and also the economic benefits that you get from tying people to long-term to the project, and avoiding, especially if you're able to migrate away from proof of work and reduce the cost of paying miners to secure the network. I think that's, yeah, I think it's, I would move toward proof of stake just based on those properties alone. So that's my view, but I don't really think too much about proof of stake stuff that much. It does come up sort of in some of the things that new versions of our consensus protocol that can give us better finality guarantees. Proof of stake plays a part of that, so I keep my eye on it, but I'm not too worried about it.
Do you think proof of stake can deliver higher throughput? Because it seems like a lot of proof of stake chains have got, very short block times compared with Zcash at least. Do you think that's that's a potential benefit further down the line?
Yeah. Throughput, I think, is not entirely what. Yeah, it's time to finality. This is the only thing I care about. Everything else can be solved with crypto, as far as I can tell. So there will be. I mean, if you're dealing with crypto, where, like, for example, just as an example, like the validation is super expensive per block, then it doesn't matter how fast your proof of or that your consensus algorithm can. This is just a crude example, but it doesn't matter how good your consensus algorithm is if your cryptography can't sustain a million transactions per second, which it probably won't be able to. If it can't sustain that, regardless of what your consensus system is, so it doesn't matter. What proof of what the thing we should fix that with cryptography and with clever tricks and so on, and I focus on that. But the only thing I need, so heads up, the only thing I need from people working on proof of stake, crosslink, everything else, just make time to finality as low as possible, because that is the real pain point that you can make a difference on, and that's the only one I care about.
Arya, what do you think of proof of stake, and how do you feel about merging it into Zebra in due course?
Oh, I would be very excited to merge it in Zebra as soon as possible. I don't think it's going to affect adoption very much in the short term, though it depends on how it's implemented. So if it does affect throughput and latency, then it could increase adoption. But in the longer term, introducing finality, I think enables opportunities that will increase adoption. And in the long term, we could work to improve latency and throughput once some version of proof of stake is implemented. So short term, no, long term, yes.
Pablo, does finality, is that something that you guys worry about when you're working on things like the atomic swaps and whatnot?
Well, finality affects everything, but this is not the most critical part for atomic swap. The thing I'm excited about with proof of stake is the fact that if we relax the requirement for complex hardware, I believe that the user base for running a proper node that validates will increase, and this is very positive for decentralization. In terms of affecting the users, the wallet holders will not be affected. So I don't see not positive and not negative effect, at least in this regard. I do see positive effect in terms of decentralization, which is important.
And Strad, Equihash is your baby, isn't it? So how do you feel about putting it to bed?
Oh, very happy to do so. Yes, that the Equihash was the literally very first thing I worked on when I joined ECC, was trying to build out a proof of work mechanism that that would be sort of somewhat more resistant to ASIC capture than existing things. And so working with Derema and others on the design for that, and then I think I was mostly implementing. And I think we can say that has served its time. It didn't quite do as we intended in terms of those protections, and in part because of things that I now very much value, but found puzzling at the time in terms of how we deployed consensus changes. But we were not going to break the consensus rules 2 weeks before we launched, so we couldn't update parameters there. But yeah, I think there are much better ways to approach decentralized consensus agreement now than there were 10 years ago. I think if we had had the kind of options that we have now, back when we started, we absolutely would have started with based on a proof of stake system. And you've seen others in the ecosystem that's exactly what they're doing now. I think the finality argument is a strong one for wanting to do this, because the statistical finality you get from proof of work is just not good enough for many systems, unless you can basically be the biggest chain in the room, which really is Bitcoin. Everyone else is sort of has to either amass the same kind of mining power as they do, or do some kind of cross-chain commitment scheme and basically hang themselves off Bitcoin's proof of work to be able to do this, which some side chains do. But I think if you're no matter what you do, that you don't get the hard finalities that you can get in a properly Byzantine system, and that just for the kinds of protocols that people want to build now, that's really becomes a requirement.
Cool. Well, we talked a bit about Zcash deprecation. We talked a little bit about the sort of the first stage or vanilla ZSAs that are coming. We've touched on the network sustainability mechanism and on crosslink. And I want to delve a little bit deeper now, Pablo, into the sort of future of ZSAs. So in the near term, we're going to be able to once ZSAs are deployed on mainnet, we're going to be able to issue assets just like or similar in nature to ERC20 tokens on Ethereum. But you guys have got bigger plans for as we already mentioned, atomic swaps. Can you talk a little bit about what the path to those features being available is, and for example, does it involve another network upgrade?
Yeah. So indeed, we started the work on the next thing in the ZSA in the ZSA progress line, and we were together with the ECC team. We were developing atomic swaps in a way that is basically most of the work is already there for the ZSA upgrade. Everything except one change is already there. The new transaction structure already supports action groups. Right now, for the upcoming network upgrade, we only allow one action group, basically a regular transaction, but the same transaction structure can include multiple action groups created by different users and combined together into one transaction. The components are already there. There is one thing that all of us needs to, first of all, conclude the design and then work on the security of this, is a change to authorization signature. Instead of signing the entire transaction, we propose to change it to sign just the action group in some variations, namely just for atomic swap. This piece needs to be finalized for the next network upgrade. For the upcoming network upgrade, except this change, everything for atomic swap is already there. On the side, in Qedit, we are working to, first of all, to demonstrate. So this is a protocol. We need, again, to propagate this through the entire stack and to create some tools, namely to match the transactions. So now we have the on-chain mechanism to settle, but we need to find these pieces of transaction and combine them together. This is a protocol happening off-chain. So we are creating a simplified version of the off-chain protocol to match the transactions. And in parallel, we're preparing modified Zebra version with atomic swap activated the way we see it now. This is happening on the side. But once again, the priority is first ZSA, vanilla ZSA, and only next atomic swap.
Yeah. I've got to say, I'm personally very excited about ZSAs because number one, it raises the possibility of bringing other assets from other chains onto Zcash, and finality plays a part in that because that makes it easier to build bridges between Zcash and other chains. But also longer term, the prospects of effectively turning the Zcash network into effectively a DEX that operates at layer one, I think is particularly exciting. And obviously, as Pablo mentioned, having the price discovery and counterparty discovery happening off chain is unavoidable, at least for the time being. But maybe at some point in the future, we'll look to make that part of the layer one protocol as well. But I wanted to throw it open, see if anybody else had thoughts in relation to ZSAs and whether they are going to be the game changer for Zcash that many of us hope they will be. I know Zai, you've talked in the past. You've said that you guys aren't hugely excited about ZSAs. I was wondering if you wanted to elucidate a little bit on that.
The thing that really excited me about ZSA is a few months ago, or 6 months ago, last time I poked into the topic, was the DEX use case. And so then when a new DEX option came up with the near swaps, I wanted to revisit, what's the utility here? I'm pretty excited about ZSAs. I am not convinced that they are offering a compelling, as I said when the question was about cross-link and trailing finality, I think there's some exciting possibilities, but I'm not going to say I think it's going to be the game changer. And I do think that before there were other DEX options, I was sort of more excited about ZSAs. I'm still excited about ZSAs, and I don't think one DEX option is sufficient. I think the more the merrier. So I'm not all in, but I'm 51% in.
Okay. So going forward, I want to kind of open it up and make it a little bit more freeform. So if people want to speak, stick your hand up and we can call on you. But what I'll do is I'll do a combination of exploring ideas that have been raised and delving deeper into various ideas and plucking out some of the questions that are coming in through the chat. Nate.
Yeah, I just wanted to offer a tie-in for ZSAs, because earlier I mentioned the network sustainability mechanism, but just in the context of it being implemented and relatively simple. But I'm excited for its potential as being something that can complement any other features that might generate fees. So it just provides like a kind of a net to catch fees if we have new mechanisms with new types of fees. And so I'm excited about that helping Zcash itself capture value if as we build more functionality and integrate into more things, and especially if we have an on-chain DEX or things of this nature, it would be really cool if that feeds into the network sustaining itself.
Are there any other features of functionality that you or any of the others think of that that could generate more fees, generate more usage? I guess there's this general positivity or feedback loop around more usage, more adoption, more fees, makes the network more sustainable. It feels like getting more people using Zcash and more frequently is has positive long-term effects. Arya.
In terms of what makes ZSAs a game changer, I think it's almost a little embarrassing to say that you can't buy Zcash on a DEX right now. So changing that is going to be really, really useful. But it's also great to actually do something with Zcash other than just make payments. So the example, I believe, at 2 Zcons ago in Barcelona that was given during the ZSA presentation was prescriptions. That's a good use case. Trading other tokens on Zcash on the Zcash chain privately is a great use case that I think would garner a lot of interest. So I think it is going to be a game changer for multiple reasons.
What about other ideas for adoption? Somebody in the questions has asked, is the integration of smart contract technology planned in the future? Why yes and why not? So programmability is something that I've personally expressed support for, but it's been more of a longer term vision for ZF because of the need to first of all build Zebra. And we've sponsored some research, and during the last Zcon there was a presentation about the results of that research. But let me turn to Strat, who stuck his hand up as soon as we mentioned that.
Yeah, no, there's a lot of interesting scope for shielded programmability, which I think is the real ask here is not just smart contracts, but shielded smart contracts. Because I don't think that there's much appetite for adding large amounts of new transparent functionality to the network, and a better solution there is to use chains that are geared for that purpose. On the topic of shielded smart contracts, I think the biggest thing that is helping to enable us in this direction is the move towards Orchard, because the fact that we can now just, as we're seeing with ZSAs, we just recompile the circuit. It still requires a bunch of work to design the circuits and implement and audit and everything. But the fact that we can just do that and not have to also pin ourselves to parameters for every single upgrade is a large enabler in terms of enabling us to try new things out. There's a lot of work that's been done in the specifically the ZKVM space. So for figuring out how to use VM-based approaches, running machine code in, or some sort of like logic code in a thing that is proven via ZKP style techniques for efficiency purposes. There hasn't been as much work regarding that from the privacy perspective, because most places that are using ZKVMs are not actually using them for ZK. ZK just becomes a marketing term rather than actually a zero knowledge aspect. But figuring out the application of proper zero knowledge to those seems like a reasonable pathway to then leverage a bunch of existing work in the ecosystem. That being said, you also have the fun things like the recent paper that came out around attacks on Fiat Shamir, showing that when you have these general smart contract systems or general computation proving and checking systems, you run the risk of breaking your proving system if the thing that you're proving can implement the proving system itself inside its own code, which is it's such a hack, and I love it. The paper is wonderful. But it essentially is showing that, like, in terms of the cryptography pieces that we're using to build our stacks, we're definitely still pulling at the edges of what is really possible to do with the pieces, with the components that we have. And there's still a fair bit of research to be done to figure out sort of decent, good, safe ways to do this in a system where we want to also ensure privacy, and therefore you're likely to not know what contracts people are depending on and whether or not they contain those kinds of problematic code.
John, you I remember quite early on in Zcash's life, you came up with the concept of pay to verification key, which was I'm not going to say straightforward, but it was an implementable version of simple programmability for Zcash, but we never actually moved forward, with that. Can you talk a little bit about what the reasons for that were, and why, for example, now you're more interested in scalability than in looking at programmability?
No, I just think that it was a matter of well, for me, the reason why I started working on pay to verification key wasn't because I was sat down and said, oh, I really like programmability, I'm going to spend some time working on this. It was actually, I think at the time, we were doing some things with Grot16, trusted setups and stuff, and we were trying to build new snarks based on Grot16 that had a property called simulation extractability, and we were toying with different ways that you could get that technique. It was just unrelated to programmability. It's just like a silly little game with cryptography. It's not really that important. What is important is that there are these things you can do with those style of zero knowledge proofs. You can basically re-randomize them without seeing them. And you can also do similar things with the programs themselves that you end up, they're the predicates that you end up proving that you satisfy when you spend some money. And when I noticed that and saw some just simple tricks, I just said, ask. I'll just post about the idea because it was so obvious to me. And it is obvious in retrospect. I don't really think it's that big of a deal. We can totally do things like that. Obviously, that the paid verification key thing, together with some of the other work that I did, kind of, I guess, inspired Zexy, which that was cool, and that's been going places as well. The state of the art in cryptography right now is so beyond what it was back then. We can do all of this stuff, and it can be very efficient, actually way more efficient than we could have dreamed back then. So maybe this whole discussion actually has me a little inspired to go back and think, ooh, have I learned anything in the last few years that I could revisit the programmability discussion and see if there is something really simple and really cheap that could be changed about the protocol that doesn't interfere with scalability, because that's important to me. But also,
yeah, I was about to say you said cheap, and by cheap you mean that it doesn't involve huge computation or taking up a lot of space on the blockchain.
Yeah, and I think that's easy though, but because when you're dealing with expensive computations in protocols like these, and you want to make your protocol efficient or resistant to, or you want to mitigate potential performance issues that have to do with performing computations, we've already solved that problem with like recursive proofs and stuff for the most part. So I'm not even remotely worried. If there's a problem in the protocol, a scaling problem that you can just outsource to somebody else, and they can create a proof that they did it right, then that solves your problem. It's just a matter of engineering at that point. So yeah, that's my thoughts on programmability.
Cool. Well, of course, none of this stuff is straightforward to do, and when it comes to merging it, we have that network upgrade bottleneck that I talked about earlier. I want to call on first Arya and then Strad, as zip editors, to talk a little bit about how you guys think we might be able to remove that bottleneck and look at being able to get new features deployed quicker. Because if we're sitting here talking about functionality that is exciting today but might not be deployed for 3 or 4 years, then we're not in a great position. So Arya, do you have any thoughts on that topic?
I think the best thing that we could do is increase the pace of zip editor meetings. Just make them longer, make them more frequent, do multiple in parallel by adding another zip editor, splitting into 2 groups. Because so far in NU6 and NU7, it's taken a shockingly long time to go over everything and make sure it's all reviewed. Much longer than actually implementing the changes that were needed. So.
Let's try to, any thoughts on that?
That would definitely help, although the meetings already go long because there is just so much zip editing to do. And because we're all relatively overloaded on the rest of our plates, it means that the zip editing mostly happens in the zip editor meetings. But yeah, in terms of the integration side, we had some discussions in Iris calls and previously about ways in which we can better accommodate changes in the code base. So getting back to the topic of like review integration, I mentioned earlier how it is easier and more flexible to sort of develop everything outside the repo and then bring it all in one go, but that does create a large review burden. The flip side currently is that if you're trying to do things incrementally within the repo, you as the person contributing changes have to be far more careful about how you make those changes, because you are potentially interfering with and having an effect on consensus code. And consensus breaks are just they're our equivalent of the Linux kernels. We must not break the user base. In our case, it's we must not break consensus. And so dealing with that is probably the main thing that I've been thinking about in terms of how to speed things up. And getting some practice in and getting some usage in with flag, conditional compilation and feature flagging things within the Rust ecosystem, done in the right way, which is the thing we're still sort of working out with this first big push of NU7 integration. I think will mean that we could potentially move to a model where changes that are being tried to be iterated on get merged earlier, but in a way that is completely segregated off from the rest of the code. Now, the main problem, like we've had actually that in place for a while, what we call a Z future flag, where we had the TCD stuff sort of hooked into various places. And generally what was happening there was we ended up in a situation where either we were paying a maintenance burden for maintaining this code that was still like, well, we may never use it, but it's there, or we would forget that it was there and be going off and do maintenance, and then, oh, it's now broken, we have to revisit it. But I would so there's pros and cons to both approaches there, but I think the entry approach, given the depth of our stack and the level to which it needs to go, I suspect the entry approach is going to become easier over time in terms of the way to do more incremental changes. We just need across everyone who's coordinating there, a consistent view and approach of how we manage that, and then who is at what times responsible for maintaining the things that are not currently part of consensus.
You talked there about the sort of coordination challenge, and I want to throw this open to the group, but maybe I'm going to pick on Za first. How do you think we can improve how we coordinate development across the different teams that are involved in, for example, at the moment, building the replacement stack for Zcashd, in order to get things moving quicker and to be able to coalesce around specific deliverables for a future roadmap?
Well, I guess I kind of want to have a baseline. Like, how do we know we're not at some kind of optimal velocity right now? So my first thought is if we had some kind of frame of reference that we could calibrate against. And then another thought, and this is just generally my opinion, is that the more observables we have about the state of the system, the better we're going to be able to coordinate. The social layer stuff is sort of secondary to knowing what we're actually working on. So I'm a big fan of focusing on test frameworks, testing. I think testing will have knock-on effects that are increasing our velocity across teams.
And Pablo, from Qedit's perspective, how do you think that as an ecosystem we can improve third parties like Qedit's ability to join, integrate into the ecosystem, and then be able to deliver new functionality into the core protocol?
So from our experience, maybe we should include another step of high-level design, because when we started the ZSA work, some of the features that are expected to land weren't there, and they appeared much later at time. If we could have been able to see it in advance, stuff like memo bundles and other changes to the transaction structure, we could have adapted our implementation in advance instead of doing these iterations of fixing and then fixing again and again. Maybe we could benefit from top-down approach for planning, not just one network upgrade ahead, but two network upgrades ahead would be beneficial, I think, to the entire ecosystem.
Useful feedback, given that we're currently struggling a bit to figure out exactly what's going to be going into the next network upgrade, let alone two ahead. I'm gonna return to the questions coming in from the audience. And there's been a few questions about the integration or partnership with NIM and how we think Zcash should tackle the network traffic privacy challenge or Tor or NIM enough? And do we consider the integration with NIM a necessary integration for transactions on the Zcash network? So Za, you've I think been the one who's been closest involved with NIM. Do you want to give us an overview of what's going on there and how you see that moving forward?
Yeah, so the Zyno stack, the indexer proxy component that Zingo Labs is primarily responsible for, has on its roadmap, if we continue to get funding, plans to integrate NIM, which is a packet layer anonymizer, into the network across the different components, with the exception of between, I guess, do we call them finalizers now, between the validators that are consenting on the blockchain. But all of the ingress and egress we plan to run over the NIM network, and I'm skeptical about the privacy guarantees or the strength of the privacy you get from Tor, because it's known that a global passive observer who can see all the ins and all the outs can then correlate and de-anonymize. And it's known that the NSA monitors the whole network. So I think a packet layer anonymizer, I could talk a little bit about what that means, but I think a packet layer anonymizer is necessary for Zcash to fulfill its privacy goals.
Okay. Nate.
Yeah, I just wanted to call out, Za, you mentioned not integrating NIM with finalizers, but one reason I like proof of stake, there's a bunch of different trade-offs with different technologies, but in terms of proof of stake versus proof of work, proof of stake is really interesting to me because it doesn't require a lot of resources. So if it's possible to run proof of stake infrastructure with network privacy, it makes it much harder for people to use force or coercion to shut down the network. Or if you imagine there's a jurisdiction that outlaws doing that, it's feasible for whoever is in that jurisdiction to migrate out of the jurisdiction without much difficulty in migrating their infrastructure. So I think that's a powerful intersection. So I just wanted to call that out.
Right.
Yeah, no, network privacy is definitely required for the full stack to be present, and in terms of providing privacy, the focus obviously of Zcash has been on providing the on-chain privacy, because that's the bit that you can't, if to adversaries who haven't captured the network traffic, the on-chain privacy question is that's what they use to analyze. Now, certain adversaries do capture all network traffic because they can, and so if you're trying to defend against them, well, you then run into the problems of, if you are a global passive adversary, do the network privacy solutions that exist even fully help there? The thing to consider here is just who is the adversary that you are attempting to defend against, and is the solution that you're putting in place sufficient or necessary to meet that adversarial goal? So, for example, the stuff that we've currently deployed in added support for in the Zcash Rust crate stack of connecting to Lightwallet servers over Tor, Tor does not defend against a global passive adversary who can trace all network traffic at all times. So it doesn't help there, but it does help significantly against defending against, for example, malicious Lightwallet operators or people who are able to sniff their network traffic. So it's still helpful to bring those in, even if they don't serve all of the network privacy goals that we have. And I want to give a shout out to to ZCG here, because the funding that led to Tor being able to build ARTI is the reason that we now have like Tor support in the Rust crates, because there weren't options to be able to bundle that kind of thing before. So I'm very glad to see that being a thing we can use now. Just getting it through the Rusts and the Swift and Kotlin stacks is a challenge, but we're getting there. And I'm very excited to see NIM get to that position within things as well. So then for the things that it works best at, which, in terms of involving padding traffic and involving the things where it is better suited than Tor for defending against, we will then be able to put traffic over those where it makes sense.
And so with NIM and this general topic of network level privacy, do you think that at some point, and obviously this is at some point in the future rather than anytime soon, I think, but do you think we should be thinking about doing a tighter integration between Zcash nodes, Zebra sort of thing, and a network privacy solution? Or do you think it's sufficient to rely on a separate solution like NIM?
I think partnering with the other communities in the privacy space has benefits that have their own benefits versus taking on that task ourselves. So I think that specialization of function, it's an interesting question I haven't considered before, and I'm not sure exactly what tighter integration looks like, but setting those aside, my answers are, I think tighter integration between communities, privacy communities, is definitely something that I'm in favor of. Maybe I want to swap my near token. I want to atomically swap my near Zcash tokens in ZSA. So maybe I want to integrate in that way. Regarding the different use cases that Strahd was talking about, certainly for stringing lots and lots of blocks during like a sync operation, NIM might not be optimal. And also, just to pop all the way back to Nathan, regarding the traffic between the finalizers, that is something that maybe we could eventually run over NIM. It's just not something that Zingo Labs has currently gotten into its bailiwick, because the finalizer to finalizer traffic isn't something that we needed to take responsibility for our first mandate of replacing the sort of the interface from outside of the core consensus nodes to the consensus nodes themselves, right? Because we came from this wallet perspective. So we're not opposed to traffic between consensus nodes being private. We just haven't come from that direction. Yeah, so I think that is at least an attempt to answer all of the concerns I heard.
Jack, you're muted.
You're muted, Jack. Oh, I wanted to say that NIM is great for broadcasting new transactions.
Yeah, that's actually something we've thought about as well with Zebra, was exposing a Tor service in Zebra that would allow you to broadcast the transaction to Zebra over Tor. But
Yeah.
I want to go back to the questions coming in from the audience, and here's an interesting one. Syncing sucks no matter what name we put on it. How can we get rid of it from the user's perspective? I've seen lots of thumbs up and positivity, but is it practical to get rid of syncing?
So, go ahead. Yeah, sorry, I didn't see your hand.
Oh no, I'll let Sean go first because I have thoughts here as well. But
Yeah, no, so this was just I don't know, that question sort of piqued my interest because I just did a talk where I kind of talked about this quite a bit. It's like a theme of what I was talking about. Syncing, yeah, syncing does suck. And so I'm hoping that wallets themselves don't have to do that anymore. To be clear, we should be able to have the same privacy guarantees in our system while letting someone else do the syncing process for us, just without giving up any of our private information to that syncing service. I mean, you're going to have to finance the service somehow or incentivize it or whatever. I don't see any way around that because the syncing process is expensive. But the fact that we can even go for this model is awesome, because in the past this wasn't something that we could really consider doing in the past because privacy implications, like I mentioned, but also the cryptography for preserving privacy, like fully homomorphic encryption, all this stuff that we would normally reach for, still hasn't really become practical for our uses anyway. And so in my talk, I talked a lot about scalability improvements in Zcash, and it turns out there are ways that we can change the protocol where we can go, oh, this is a problem, that's a problem, that's a problem, on the side of the validators or on the side of the users. Let's move it so that it becomes a problem of someone on the syncing side. So instead of applying all of our crypto tricks and magic on the side of the validators or on the side of the users, we apply it to solving the privacy problem, to outsourcing all the effort in that goes into, for example, syncing, or proving that transactions are valid or whatever, that we can outsource that to other entities and to make our lives a lot easier. And I think that might be a better approach to, or at least it will open up new avenues or new like right now we've sort of hit a brick wall trying to solve these problems with cryptography. We need some new ideas and approaches, basically. So my dream's a future where syncing's done for you and your wallet doesn't have to do it. Your wallet doesn't have to be online all the time. You open your wallet up and it's kind of like when you open a banking app, you get your ledger information from the bank, and they do all the hard work in the background to get you a balance and show you your transaction log. And so the problem, of course, is that they have the keys to your account, really. And they also, the other problem, the more important one, is that they also know everything that is happening on your account. And so I wouldn't mind a model personally. I think it's totally a reasonable, it's a reasonable model where you choose your service, but you keep your keys and you keep your privacy. So that's sort of where that's my headspace on that.
Strat.
yeah, the thing with regards to syncing is fundamentally what we are trying to achieve with the syncing process is anonymity via a broadcast channel. What you want is fundamentally to see everything, and then you know how to pick out the bits of the network that are for you. In other systems that don't use essentially broadcast anonymity, you get much weaker privacy guarantees to the extent that any that are claimed generally collapse under scrutiny. And so the downside to that is you need to see everything, which doesn't scale. The approach that some have suggested in the past, and that I and others have strongly pushed against, is just providing your viewing key to a central service. Now, if that service is a service you run, that's perfectly fine, and that's actually something I'm very excited about with the Zcashd deprecation. The resulting stack, it would not be that hard to massage it in a way where you can then run your own Zebra node and essentially full wallet service on your home server or something. Like if you have a Synology or a QNAS, you could install an app that does all that and runs it for you on your home network, and then via Tailscale or something, your phone is then communicating back to that and relying on it. So essentially serving that service without any need for any new changes to cryptography, because you're giving your viewing key to someone you trust, yourself. if you want to get to the point where you're doing the equivalent of something like that to someone that you don't trust with your privacy, that's where I haven't seen Sean's talk, but I'm interested to go and see the things he came up with and was presenting there. Ideas that I am aware of are things like fuzzy message detection and ideas along that route, which are basically attempts to give you they leak some amount of information to the server doing detection. They learn that you are within this particular subset of the network rather than specifically what transactions are yours, but they do still learn some amount of information. And so if the Holy Grail is is a technique that lets them essentially do the exact same pick things out as their going process, but where they don't learn that any particular pick out actually updated the state that they're sending to you. And if there's ideas around ways to do that that don't rely as heavily on homomorphic encryption things, then I'm very excited to hear those.
Have you looked at oblivious message retrieval as well?
Yes, the OMR stuff is very interesting, but also a bit tricky. Oblivious message retrieval and sort of the general schemes of private information retrieval are very commonly used in private, enterprise and in commercial businesses. Pretty certain that Apple and Google both use them in various cases. And the premise there, for those who aren't aware, is that the server has a database and the client has a query, and the server shouldn't learn what the client's query is, and the client, in some cases, the client shouldn't learn what the database is. We don't care about that in this case. The main problem we have is that the database is always changing and always updating. Most of these deployments of OMR or private information retrieval schemes rely on the ability to do a bunch of pre-computations and on the state of the database to then run the operations with. And for an ongoing chain, that becomes very costly to do and hard to keep up. There have been some interesting PR and OMR schemes in the last couple of years, though, that in terms of improvements to efficiency or different ways to sort of split up how things are done, such that one place that I am interested to use this is to see if we can use it in nullify detection for spend detection. So it's the other way you could take this syncing discussion, is splitting up the things you care about syncing and applying specific technologies to make those more private and efficient.
You could definitely talk with Sean then about that.
Yeah, you should check the talk out.
Aria.
So I think it would be really nice to just host the service on your own computer and access it via Tailscale. But if you want a paid service, you could just deploy the same thing to AWS or Google Cloud. And it would provide a much better user experience than what we have currently with wallets.
With the downside that then AWS is able to see all your transactions. So if you're willing to pay that cost, if you're willing for whoever is hosting that service to, one of their engineers can go in and have a look, or anyone who's potentially who is running on the same server host, because you're just one VM of many, anyone who, using cross VM speculation attacks, of which there are many, and that's a fertile ground for information research. If you're willing to operate in that environment, then yeah, that's probably better than paying for someone who advertises themselves specifically for this service, who could then just be collecting viewing keys. Because once you've given out the viewing key, you can't revoke that capability.
What's that phrase? There are no solutions, there are only trade-offs. Aria.
You could do it with only part of your funds and take the same sort of risk you take when you put cash in your wallet and walk out the door, and you might lose that money. You could lose that money to AWS as well, but as long as it's just what you need when you're walking out the door, then it should be okay.
It's not a question of loss of money, because you're not putting the spending keys on there at all. It's a question of loss of privacy. And so to some extent, that would almost be worse, because that would imply that this is the wallet you're using for your daily transactions, for your active transactions, and therefore has the most activity on it.
You're right.
I'm gonna pick up a question that's coming from the audience about liberated payments. Since liberated payments require a direct connection between sender and recipient, doesn't this impair sender anonymity? And I wanna link this a little bit to a topic that Zah wants to talk about. Oh, so he's raised his hand straight away around messaging. And I also want to ask Sean to chime in after Zah to talk about something that he said during his talk, which was so interesting and so apt that I noted it down, which is all in-band secret distribution needs to be removed from Zcash in the future. You need to learn about your notes out of band, and nobody can use the blockchain efficiently as a messaging channel. So with that, let me turn it over to Zah.
The messaging use case might, I don't think it would entirely migrate off chain. Let me lower my hand. But you know, the Zcash blockchain is a massively replicated database, so it's never going to scale on its current incarnation as a message store. But I think it's good enough for proof of concept, and we have some proof of concept stuff we'd like to show. Per the liberated payment linking the sender and the receiver, that's not really a drawback in the case of using liberated payments to onboard into messaging, because the point is to send messages back and forth. There's an interesting thing, I like to think that entering the messaging space is sort of diversifying Zcash's utility bets, right? Like, payments is a great use case, and it's a market that we have a bunch of unique features in. That we're the most private, and it's a market that we hope to do well in, but that shouldn't hold us back from entering the messaging market, which is huge and critical. An interesting kind of thing that I'm seeing in this moment is that the liberated payments mechanism is one, like a first example, hopefully of many, of sort of bootstrapping activity across those two. If you want to split the use cases into these two different sectors and say that payments is one thing and messaging is another thing, but of course there's crosstalk all the way, and the liberated payment is an example of this thing that has utility in both spaces. So I think, and for the case of messaging, per the original question, the fact that it's binding sender and receiver is a feature, not a bug.
Yeah, my own view on messaging and sort of integration with Zcash is that if I send somebody a Signal message or even a WhatsApp message, I've got a pretty high degree of confidence that the person at the other end is the person who I want to receive that message. And thanks to Signal and end-to-end encryption, I've got a fair degree of confidence that it's not going to be read by anybody else. So for me, the natural progression as applied to Zcash and scalability is, well, why not use those sorts of channels for transmitting note information to the recipient of a payment. Nate, you put your hand up and down a couple of times. Come on, come out with it. Let's hear it.
Well, I feel like you and Zah both hit on it, but it is really powerful for a different use case where you already are connected to someone in a totally different protocol or system. You already have that connection, and now can we enable payments over that of Zcash? I think that's really powerful, because there might be, people are using all kinds of different systems, and if the payments can be going over those systems, it could be better for scalability, and it can be better for privacy for people who are already connected. So it might not be better for, I'm going to buy something from a darknet market and I, go to the website and I'm using it that way. I'm not sure it helps as much with that, although it might still help with scalability for that kind of use case. So I thought the question was focused on a particular kind of use case that I see as like a subset of what Zcash can do.
Sean, do you have anything to
No, yeah,
chime in
no,
here?
Nate said exactly, or mostly exactly what I was going to say, which is that, I mean, the question sort of asks, like, so since liberated payments require a connection between the sender and the recipient, doesn't that make it so that the sender isn't anonymous? I forget what the question was, something like that. I mean, yeah, Nate already said pretty much what I was going to say. The whole point of liberated payments is that you reach for them because you already have a connection to the recipient. So whatever it is that your anonymity or lack thereof with the recipient, that's what you fall back to. Liberated payments doesn't change that at all. It's just a yeah. There are other, if for example you need to be able to have anonymous communication with your recipient, there are other ways to do that. There are other payment flows that potentially don't involve liberated payments, or that might be more efficient, or yeah, whatever. There's other payment flows that can establish that anonymity potentially.
Right.
Yeah, and to build on that, the purpose of a payments network is to essentially mirror some kind of social graph in terms of and mirror that in financial flows. So if you already have a social graph to leverage, being able to route the payments directly along those edges of the social graph means that you don't even need to worry about someone who is trying to analyze the on-chain behavior, because the actions aren't on-chain. If you can avoid that, and this ties back into the making syncing better as well, because if the sender of a transaction has given you the transaction directly, you don't need to scan for it. You know it. And there's tricks we can do in terms of for the recovery from seed case to make recovering state better, mostly centered around either, like, while we have on-chain storage, storing stuff on chain, or just more more resilient backups of in your own personal backup cases. But in general, the point-to-point transfer model is going to be much better for detection latency and scanning performance than any kind of, and better for privacy than any kind of on-chain stuff we do, because you're essentially falling back on an existing channel you already have. This sort of gets into the same vein as you should just use Signal for everything you're doing in messaging, because then it's normal. Your network traffic doesn't belie the fact that you're sending around Zcash transactions. You're just messaging with your friends. And if there happen to be Zcash transactions conveyed within that, then great.
Thanks.
Yeah, I totally agree with everything. Like, I feel like we're all on a similar page here, but I do want to point out that, syncing sucks in Zcash, but the reason there is syncing is because it's providing an anonymous broadcast feature, and that's actually pretty rare in technology. So that is valuable. And I think, we should be thinking about ways, when we're talking about, like liberated payments and scalability, there's still potentially a lot of value in anonymous broadcast. So maybe there's still a system that can provide that. Maybe it's not a Zcash system, or maybe it's a Zcash system. Either way, it could be integrated with Zcash, because that does address certain use cases, and it's pretty elegant for those use cases.
Cool.
Yeah.
Well, we're very close to time now, so I wanna wrap it up with a kind of a final sort of 30-second response from everybody to this question. We're going to do it in reverse alphabetical order, so we'll start with you, Za. If you were appointed the benevolent dictator of the Zcash ecosystem, and you could persuade or instruct or order every organization in the Zcash ecosystem to work on a single sort of deliverable or project or what have you, and assuming that ZSAs, with no ZSAs, and the NSM have been delivered and whatnot, and assuming that the funding was all sorted, what deliverable or project or feature or protocol level functionality what problem would you want us to solve and focus on? Za.
I definitely don't think there would be one problem that I would advocate for everyone to focus on. I think that reality can be a snarly, surprising thing, and I think I would dictate that we should diversify our bets and have multiple threads of R&D and innovation going on, so that some of them can fail and hopefully some of them will succeed. So I would say I would put all my money on diversifying into more than one thing.
So basically, what we're doing at the moment.
Yeah.
Strad.
Get rid of the transparent pool.
Short and sweet and to the point. Sean.
I was going to say what Za said, but then Strad mentioned the transparent pool, and I remembered how much I hate that thing too. So I don't know. Yeah, I think that it's awesome that people are working on a ton of things in Zcash right now that I don't really even care about myself. Like, I don't really care about ZSAs that much, but a lot of other people do, and that's awesome, and it gives them something to work on, and it's involved with Zcash, and I will admit there are very compelling use cases for it, and it's I've been convinced of that, but I'm not passionate about it. I would not want everyone focused on a single problem. But to get to the spirit of the question, which is mainly not should everybody work on the same problem, it's mostly like, what problem do you think maybe to get the spirit of the question, you're asking like, what's something that we're not working hard enough on, one particular thing maybe we could put more resources into. Let me think for a sec. I would have said getting Zebra across the finish line, because getting Zebra and getting Zcashd deprecated and getting Zebra to be used and to be the springboard for all the rest of the other projects in the ecosystem to get their ideas implemented and testing and maybe deployed in Zcash. That I would have said that, but we're almost at that finish line now. We're getting close. I mean, I don't want to jinx things because there's still a lot to do with deprecation of Zcashd, for example, and but I would say getting ecosystem partners, getting miners, getting exchanges and stuff to actually somehow getting them interested in updating and getting away from Zcashd as fast as possible is probably the thing that's that we aren't spending enough resources on, because right now those entities are holding us back from the potential that Zebra has to unlock, because we're sitting here spending so much time trying to keep their services working, and so I don't know the exact solution to that. A lot of it's outreach, but yeah, that's definitely it unlocks so many opportunities for Zcash for us to be able to get rid of Zcashd. That's what I would say, I guess.
Yes, step one to that objective is getting the stack complete so that we can say to people, right, it's ready to go. It addresses your use case. Here's how you deploy it. Please test it out. Let us know if there are problems. We'll fix them and then get migrated. And once that's done, we'll be able to move forward with NU7.
Yeah, that's definitely step one. But in my experience, and I'm sure that you would agree, that these people don't care if you get step one done. They don't care. If they can coast on your old tech stack, they're going to do that as long as they can. And that's really frustrating, but it's just reality.
But getting step one done is a prerequisite for, you can't go to step two without getting step one done, It's a hard prerequisite. You can't get people to migrate off Zcashd if there's nothing for them to migrate onto.
So, I totally agree.
So yeah. Pablo.
So if I had to choose just one thing, I would go with the user experience. If we task the user with syncing and we task the user with running home servers or AWS, it will always be some kind of a niche experiment and it will not go mainstream. The user had to, it's like with the Signal example. So Signal is very simple. It's like WhatsApp, and the user doesn't care that the cryptography is more evolved in Signal. So I think Zcash should strive and to follow this pattern and to be as simple as possible for the user, minimal requirements, and then we can talk about more cryptography, more features, more other things.
Yeah, I do suspect that we have potentially a lot to learn from an organization like Apple, which seems to have figured out how to deploy very strong cryptography in a way that doesn't impact the user experience negatively. Nate.
Okay, hear me out. It's a sequence. Add finality, develop bridges, use that to make layer 2s, and then do something like eigenlayer, where layer 2s connect to the base layer's native token, Zec. Because once we got there, then we could start deploying new functionality and new protocol changes in separate layers without blocking on each other.
You should check out my opening presentation where I talk about building bridges and making it possible to create Zcash sidechains, so we can remove that bottleneck on trying to get everything into a single protocol. Well, finally, Arya.
I have the same answer as Nate if I can pick multiple things. Otherwise, I would go with liberated payments because I think it improves the user experience the most for just one thing. But proof of stake and bridges, I think, are the winning combination.
Cool. Well, we've been talking for over an hour and a half, and I feel like we could keep on going for another hour and a half quite easily if people didn't have to take bio breaks. But if you're watching this and you're interested in these sorts of discussions, then I would encourage you to point your browser at zcasharborist.org and get those arborist calls into your calendar. That's where the core teams come together to discuss changes to the protocol, coordinate network upgrades and stuff like that. And that's the regular place where these sorts of conversations take place every couple of weeks. And all of those calls are recorded and uploaded to YouTube, so you can go back and watch the history of them all. But for now, I'd like to thank all of the panel participants for setting aside such a big chunk of time out of their day, and we'll leave it there. I think next up on the agenda for Zcon is a presentation from ChainSafe. But for now, we'll say good night, good afternoon, good evening, wherever you are, and thank you all.